And in this session, we're going to spend time with Intel. I've got Thomas joining. Thomas, welcome.
Hey, thanks for having me. Really, really looking forward to this.
I am as well. And so let's kind of set the context kind of broadly. So certainly the needs for AI connectivity are much different than the data center and traditional enterprise network. So I'd love it, Thomas, if you could spend some time around how Intel sees that.
What really sets it apart from a traditional enterprise environment is you really have these very expensive GPUs, not just CPUs, but also GPU-based servers for AI. And you have a need for reliable transport. And there are different ways to do that. But you really have a need for reliable transport to minimize the downside of the expensive compute cycles, whether CPU or GPU, to get actually the best outcome. And as we all know, these products are not cheap. If you want to get to the TCO, you need to use them as much as you can, which means you need to have a reliable networking infrastructure. So that's, I think, where it starts. And so then the next one, when enterprises look at this and saying, hey, I have Ethernet deployed everywhere today. Love the operational simplicity. Ideally, you do not have dedicated fabrics. You run everything over Ethernet. And so now the next question then becomes, how do I make that happen? How do I advance what I have to do today with Ethernet and make this reliable? So there are a couple of ways to think about it, and that gets us a little bit on where the industry is going and where we as Intel driving together with partners into ecosystem. The different ways to do what most today actually do, I want to say pretty much everywhere in the Ethernet world is, you say, hey, to get to reliable transport, I make the fabric lossless on the Ethernet level, which is really the RDMA or converged Ethernet. Most people just use it like Rocky. And that's basically what it is. You need a it's proven, but it takes settings and optimization in an Ethernet fabric to make that happen. And then the second way is to do, hey, I just assume my Ethernet fabric is like it is today for pretty much every application, a lossy fabric. And then I need to implement a protocol on the edge, on the servers, on the NICs. And this is where the Intel IPU comes in, with a protocol such as Falcon, which was open sourced by Google, to actually get to the same outcome, which is a reliable transport over an Ethernet fabric. And so this is, coming back where we open up is what's different. You want reliable transport for AI workloads, and you want ideally doing this on Ethernet because customers just love the operational simplicity of Ethernet.
But there are also some other advantages, right, relative to other proprietary architectures. For example, it's more open. There's more flexibility.
It's really a couple items. They do want a standards-based solution. They do want an ecosystem because they do want choice to have various vendors in this market. And it's not just because they like more than one vendor. It's just if you have multiple vendors, you just have better risk diversification. At the end, you do want a technology that does the job, which gets us then a little bit into where the standards are going with Ethernet, because Ethernet is around, to your point, forever. It's the broadest installed base there is by far. And so calling out some of the other ones, right? And I'm like 20 plus years in this industry. I remember we were talking initially, like there was not in the data center world, but we're talking like ATM and SONET. All those became Ethernet and IP. And then you had fiber channel. All of this moves onto IP and Ethernet. And then you have Infiniband, which was always in that corner for HPC, high performance compute environment. And so this is the latest discussion, right? Hey, can we make this work on Ethernet? So we basically have the volume, which drives then cost and innovation much faster with Ethernet. And so really the whole discussion is how can I use Ethernet to get to reliable transport similar to what Infiniband can do today in a very specific niche. And so that's really what customers are pushing for and what the industry is stepping up to deliver.
Intel is very open standards oriented, with x86 and what you're doing from a networking perspective. But can you speak to some of the other advantages with open standards?
Yeah, maybe a couple points, because you said is an ecosystem. I mean, I basically look at this. If we're looking at the AI, and I don't like to use the term explosion, but the tremendous growth that comes out of it just from a network connectivity perspective, which is real, right? It's very clear, and this is going to go on for a couple of years at least. There's no doubt in my mind. And I don't think this is about, are you first or are you the only one? The market is so big. I mean, it's just there's plenty to grow for everyone. So that's why I actually look at this as an opportunity. Now, number two, in terms of performance, there's this very technical debate going around Infiniband, and I pick Infiniband because that's the piece where the Ethernet Infiniband Ethernet transition is where it's going to happen. Is what most people call the scale out network, or what to put a note on there. This is basically how do you connect GPU servers to other GPU servers. That's that scale out network, very high bandwidth. Between server nodes or racks, depending on what design GPU server design you're on. And realistically, as I said, what it really comes down to, get to reliable transport. You want to minimize latency. You want to minimize the time it takes to do retransmission, right? And so, as I kind of alluded to, there are two ways to do this. One is a very expensive way. This is what Infiniband does. You really enforce losslessness. However, that takes away some of the scale-out, large-scale ability, where you say, hey, if I can take some loss, but I do very fast retransmit, selective retransmit, can react very fast to congestion and route around it, or steer traffic around and get to reliable transport that hits my performance criteria. Now I can scale out to very, very large fabrics, which is where the trend is going. And so this is really where Ethernet is going to shine from a technology perspective. And quite frankly, based on some of the initial data that we're seeing, we'll actually do the same and better what Infiniband can do today from a scale perspective.
And from my perspective, a lot of the innovation is being driven through the Ultra Ethernet Consortium. And I know that is something that Intel is very involved in. And I'm wondering if you could spend a little bit of time for our viewers and explain what are the goals and how is Intel specifically contributing to the UEC?
Yeah, I mean, the UEC, I want to say it probably started over 12 months ago when this came into, when the awakening happened, quite frankly. ChatGPT was like the seminal moment when people realized, man, this is so easy to use this technology. Now let's figure out where we can use it. Everybody said, I can use it everywhere, which is true. And so Intel is a founding member of the UEC because we looked at this and saying, and to your point earlier, we're a big proponent of open standards and enabling ecosystem, right? Not only on the Xeon side, but on connectivity as well here, right? And so the mission really is, if you look at the UEC, it's an Ethernet-based, open interoperability, high performance, full communication stacks architecture to meet the demand, not just what HPC did in the past, but to what AI needs now. And so this is where the focus. And if you look at, there are different knobs what you can turn. There are layer 1 working groups, layer 2, layer 3, and then there's where you go at the WIRPs and the lip fabric layer. What are some of the optimizations to do to actually deliver truly reliable transfers, optimize low latency transport? And so Intel is participating in these very working groups besides being on the steering committee as well. And we're quite frankly seeing, if you look at the membership, it's just the whole industry is coalescing around it. I think at this point, it's pretty much everybody that plays in that space as part of the UEC and is pulling together.
That's great. Let's dive a little bit deeper into Intel's portfolio. And Can you provide some examples of what you're doing, to your point, to drive AI connectivity at scale out speed?
Yeah, and you bring up a good point, right? Because there's a little bit, whenever you have these, it's not a hype cycle. Whenever you have these initial run, right? People focus on the high end, right? I need the next one. The high end is real. So don't get me wrong with SD. I need the next 16,000, 32,000, 48,000 node large learning model clusters. And these are real. These are happening. Quite frankly, what's really interesting to me is the build out cycles I'm used to is every 3 years you build another version. In the AI world, we're in a 12-month build out cycle on the high end, which is super interesting. And again, it comes back to, it's actually an opportunity for the whole industry, not just Intel, it's for the whole industry.
Well, and these GPU clusters are massive, right? So I spent time at GTC. I was at Dell Tech World this past week, and it's just mind blowing, right? And you've got to have the right level of connectivity to make the plumbing all work.
Yeah. And where we're going with this is that what's a little bit sometimes is lost when you're in that initial stage when the market is just booming. Everybody talks about what do I need in the high end, right? Because it's like the next biggest thing. And that's important. That's what I'm saying. And so that's really where you do need to have reliable transport and optimization to get the best performance out of it. Because, again, these GPUs are not cheap today. Part of them, as the way I think about it, because they're really general purpose. And one of the trends you will see, and I got a little bit off track here, but I think you see over the years a lot of indications out there. You will have a lot of purpose-built GPUs, some customers or service what I call them TPUs, or accelerators, but that will come over time. But today, what you have these general purpose, very expensive GPUs, and you want to run them at the optimal utilization because time is money. And so that's one. This is where you want true reliable transport, and this is one of the things what we have implemented was Falcon technology. And this is where the UEC goes as well, and we will see more optimization in that space. However, there are also a lot of like smaller clusters. Think about like 1,000, maybe 2,000 GPU nodes. Those ones you can actually do today, and I have seen this with enterprise customers as well as actually some of the service providers to the CSPs today. They're deploying Rocky V2. It takes a lot of tuning. But for smaller clusters, you can do. And in this world, you would use an Ethernet adapter. So in the Intel portfolio, you would use the foundational, like the Ethernet controller, the 800 series, or you can use the Intel IPU adapter that also supports Rocky V2, and then you're sent for larger scale clusters. You can use then Falcon as a protocol to get a better reliable transport solution. Main point really what I'm trying to get across is if you look at as an enterprise, and I start today, you take your existing Ethernet fabric, you can have two choices. You can turn on Rocky V2 for the nodes that you need lossless Ethernet to support medium-sized clusters. Works perfectly fine. If you want to have a better performance, you would use an IPU NIC. You don't actually have to do anything on the network at this point. You don't have to turn on the lossless features. You just use a lossy fabric and run Falcon between the endpoints using the NIC. And then for the very large cloud providers, they will go down this path of what USC is working on, a truly fully optimized Ethernet solution for reliable transport.
And I'd love to touch on what you're doing from a software perspective as well, because you're a leader in silicon, but software comes into play, and you've touched on this a little bit, but I know that there's one API and then there's the Intel Ethernet Fabric Suite. Can you spend a little bit of time on those points as well?
And that's a very, very important piece, because it's so fun, particularly for people, admit on my history coming out of the hardware silicon world, it's so fun about talking about performance, what you can do, but unless you have the right software abstraction layer and make it easy to consume, quite frankly, a lot of this doesn't matter. And so what is really interesting in the space, with Intel, we have this product called the Intel Ethernet Fabric Suite, which actually was built around HPC, high performance computer environment, which is actually very transferable to what is needed in the AI world. And then obviously we're pushing around one API. And so if you look at us, what is really needed in this space, applications built for the AI world more and more are either based on PyTorch or riding on top of a particular as awareness communication library. And what you really would like to do here to actually enable an ecosystem, you want a software layer that can plug in on the top to what PyTorch does to do when you build against that, or the communication library on that particular vendor. So you don't have to change that, what you do today. have that fabric suite in the middle, and then underneath have the drivers plug in from a broad vendor ecosystem, right? Not just Intel NICs, but also ecosystem vendor NICs as well as switches. And so basically, again, on that software layer, provide a high performance open source layer that people can build on. So you actually enable the adoption, accelerate the adoption of reliable transport mechanisms for AI workloads.
Besides connectivity, I mean, Thomas, from your perspective, what else is important as enterprises consider taking this journey to the next generation AI?
I mean, this is all about unlocking the value of data, right? The goal is the data, and how do I get to the value of that data faster using AI? So we covered this, right? And I think that's the important piece because, again, GPUs are not cheap. Connectivity needs to make sure the GPU is humming and not sitting still, right? And that's very, very important going forward because, at some point, you need to be able to make this a good TCO case and a good ROI over time. There needs to be some return. And as I say, there are multiple pieces besides the network needs to make sure the GPUs are humming, and then obviously you're going to start optimizing. Do I really need the biggest GPU for everything, or do I have some optimizations going on for certain use cases?
One of the biggest concerns is around the power envelope. Yeah. And everything that I'm hearing from silicon providers, including Intel, is around what you're doing to drive a more sustainable set of silicon, right? That's super important.
You absolutely have to do that. And then the next piece that will come, and you see this, some of the articles, which is, I think, is very obvious because it is data, right? And you're trying to unlock the value of data. And a lot of this is data that is proprietary information for enterprises. Might be customer data that you want to use, the application, what do you want to drive value? And I'm not talking about hey, how can I answer the general question on the internet fast? I'm talking about, let's pick an example. I have a customer calling in for support. I want to go through all the data I have about this customer and using an AI model to come with a good answer up much, much faster than normally, right? And so I think that data you need to protect, right? And so data is needed everywhere. It's needed for training of the model. It's needed for answering the question, for the queries, for the inference. And so you need to build in these AI infrastructures security for the data going in, data going out, data in flight. You probably, when you tell me saying is like, yeah, Thomas, this sounds very similar to a lot of the other things where we talk about security and networking. And the answer is yes. So what needs to happen here, right? When we build these AI clusters, our customers building these AI clusters, you need to think through how do you protect the data going in and out? How do you protect the edges? And so this is where actually I spend a lot of cycles with the product set that I have, which is the Intel IPU, is to think through not just can I get a reliable transport, but can I actually add security? And the beautiful thing about the Intel IPU is I actually have an embedded CPU complex that can run a lot of the security functions inside of that NIC. So when you have data coming in and out of a server, I can actually intercept and do a lot of these things there in terms of encrypting, authenticating, seeing who has access, reporting on who has access. And so this is a very, very important piece, particularly in the enterprise where you're worried about where's your data going. We actually work very, very closely with Red Hat, given that we have a lot of joint customers in the enterprise space. On inboxing our Intel IPU with Red Hat OpenShift and Red Hat Enterprise Linux. And inboxing really means making sure it is supported out of the box when you support this. For developers that are looking at using this. And so the reason why it's important, again, because we basically give access to the CPU complex that is embedded in that IPU NIC for developers to run their security functions on there. It becomes very, very easy for them to use their standard tools they use today to also manage that little protection enclave island on the IPU NIC. So back to you.
No, I'm glad you touched on security because it's a huge issue. I mean, not only data security, data sovereignty, but protecting the large language models as well. I mean, there's IP that's tied to that. Can you share Intel's vision for AI connectivity?
So broad partnerships, standardization and open ecosystem are probably the top three for us where the vision is in the space.
And Thomas, thanks again for a great conversation. We could probably keep talking for another hour or two.
We'll take you up at some future point. No, really appreciate it. Thanks for the time.